Stars You Should Know on episode 294 of the Actual Astronomy Podcast. I'm Chris, and joining me is Shane. We are amateur astronomers who love looking up at the night sky. And this podcast is for anybody else who likes going out under the stars and asking, what are your favorite stars? So we have Dave Chapman joining us today. He has been on the show a few times. He's a former editor of the RASC Observer's Handbook, and he's also a past observing chair. And amongst lots of other stuff, I've worked with Dave lots in the past. And we'll just welcome you back to the show, Dave. And by the way, congratulations on your new book, Mi'kmaq Moons, which you did with Kathy LeBlanc.
Yeah, well, it's a pleasure to be here. Thanks for having me back. We'll see how this goes.
Yeah, because we were chatting there before. If it goes well, maybe we'll do a few of these. So I like the idea. All right.
Right on.
All right. So where do you want to start here, Dave? So I see in the notes we're looking at, we got focusing on classical Greek and Roman names and occasional indigenous names. And how do these relate to like go-to telescopes and computerized software and sky?
Well, that's not that's not a primary focus of this. But I guess I came across the idea a while back working with John Reed. You know, he's put out a few books, 50 things to see on the moon and, 50 things to see in your telescope. And I said, hey, I'd like to do one, maybe you could help me with it. 50 stars you should know, right?
Yeah.
And in other words, like of all the stars that are out there, I'm going to clear my throat. Of all the stars that are out there, which ones should you really know about? What are the most important ones and why are they important? And, and most of the ones that I've thought of had names. And so then they have stories that go with them as well. So I came up with this idea, but of course the 50 stars you should know quite rapidly became 100 because for each star that, each important star, there's always like a nearby star that's also interesting. So it was always going to be like 50 plus, 50 stars you should know, and then a couple on the side. So what we're going to do here is I have them all divided up through the seasons for the Northern Hemisphere and also the circumpolar stars. So I've got 6 groups of stars that I've got. And for this episode, I've got it down to about 11. 11 really important stars that you should know in the winter sky. And so people, after listening to this, they should be able to go out the next clear night and with the assistance of like a star chart, or, it could be just something on your phone or in a magazine or a very basic star atlas. You should be able to go out and look at these stars. You don't need a telescope or binoculars. You should even be able to see them in the city because they're all more than second magnitude.
Okay.
So that's what we're going to focus on this time. And I'm going to the Greek Roman thing is I'm using the kind of classic mythology for this because that's what most of the stars have been. Most of the stars have been named after classical mythological figures and so on. But occasionally, we're sensitive to the fact that there are other cultures in the world, and they, we all look at the same stars, but we have our own stories. So I'm trying, when I can, to identify some of the indigenous references that go along with that. But to do more than that would require a lot more time, I think. So, and the other reason that you should know stars, other than that they're just darn interesting, is that if you do have a go-to telescope like a Skywatcher SynScan or a Celestron, these star names are used in the hand, the hand controllers when you want to align your telescope. Okay. They say, okay, well, what stars do you want to use to align your telescope? And if you don't know the names of the stars and where they are in the sky, you're kind of lost. So all of the ones we're going to talk about today are Skywatcher SynScan alignment stars. They also all happen to be the standard standard stars used in celestial navigation. When people go out with sextants and stuff and shoot the stars, and all of that. I don't know if anyone does that anymore, but they have a history. So there's 58 navigation stars, and this is going to be like 11 of those that are in the winter sky. And
Okay.
I was a bit biased towards choosing those because they are the brighter ones, and they're scattered across the sky as well.
I like that mention about like the go-to controllers and alignment, because probably 10 or 12 years ago, I got my first go-to, and it was a Celestron Next Star mount, and I put a little Maksudov on it. And my first night out, went through the alignment process. And at that point in my observing life, I knew where lots of globulars and galaxies and nebulas were in the sky,
Yes.
and I could identify the constellations, but I had not learned the stars. So
No,
when it came time to do the alignment, it was like, what is this even telling me?
I have a funny story that goes with that. I was out at St. Croix Observatory, our club observatory, and I was out there with an astrophotographer whose name will go unmentioned. And he said to me, I was doing observing and he was photographing. He said, well, he said, I want something different. I want to look at something different. And I said, well, I don't know. What are you interested in? He said, what about one of those dark nebula? And I said, well, there's Bernard's E Nebula. And he said, well, where's that? And I said, well, it's right next to Altair. And he kind of gave me a blank look and I don't know where that is. And I was astonished. I like, what do you mean you don't know where Altair is? Like, it's, anyway, but I think it's a common refrain these days because people get into these, into the hobby electronically, and quite a lot of people don't learn the sky, and so, they're punching in coordinates or punching in things from a database, and the telescope slews to them, and there it is in the telescope. But they've skipped over that whole part about learning the sky and the constellations and the star names. And even I didn't know all of the names, so I kind of set about learning them. So one of the things we're going to talk about is spectral classes. So the stars have colors, although to most people's eyes they're fairly pale colors. They're not brilliant, saturated colors. And so there's a spectrum, which was the star classes that were introduced by Annie Jump Cannon probably more than 100 years ago. And from white to red, it goes O, B, A, F, G, K, M. Now, I'm not sure why she ended up with that particular sequence. And there is a mnemonic that goes with that, but I feel like I'll let people Google that for themselves rather than to give it to them, because some people find it a bit objectionable now. So anyway, I'll repeat that. So O, B, A, F, G, K, M. So O, B are like white stars. A, F are kind of yellow stars. G, then you get into the oranges and the reds, okay? And I'll be talking about those spectral classes. And I'll just quickly, the references are in the notes. I won't read them out. The notes are going to be available, so you'll see the references that I've used.
Just a quick note too, Dave, about that. We'll post the show notes on actualastronomy.com. So,
yeah.
As Dave is taking us through this journey, you don't have to worry about, feverishly writing everything down or trying to memorize it all.
There's a lot of data here, and I'll try not to dwell on anything too long. And I want to make it interesting too. So I'm only including information that I think is particularly interesting. I guess the only other thing I want to say is, I think if people have the time, they should grab a star chart or pause the podcast, go get a star chart, because I think it'll be a lot more clear if you have something like that to look at while you're listening.
Oh, and Dave, maybe we should do a very, very, very brief bit on stellar magnitude, like what's a bright star and what's a faint star.
Oh, okay.
Just for context. Thanks.
Well, did you want to do that?
No, I think we're good if you want to do it or Shane wants to do it. Like,
Shane,
my voice is still not all there, folks.
Maybe Shane can remind us about how magnitudes work.
Yeah, well, there's I guess maybe two classes of magnitude. There's like the visual magnitude that we see from our location in the universe, and then there's the, I don't know if it's true magnitude or what the right term is, but the actual brightness, which is a whole nother way of calculating it. But for the most part, what we talk about is visual magnitudes, and it's just an indication of how bright something is in the sky. And I'm trying to think of what some of the well-known magnitudes are of, say, like a full moon. I can't remember that offhand.
Well, magnitude like negative 12, negative 13. I think the sun's like negative 26.
Yeah, and it's kind of a funny scale because, normally, the higher a negative number is, it means less. But in this case, a high negative number means extremely bright. And if it gets to the other side of the scale, like on the positive side, it's getting darker and darker all the time. So I think, a lot of stars that are considered to be on the threshold of naked eye brightness is usually around like a +6. If you're living in an urban center, sometimes magnitude 2 to 3 is about your limiting magnitude. And what we mean by limiting magnitude is just what you're able to see with your eyes.
Yeah, well, I think the magnitude system comes from language. People didn't have, at first they didn't have numbers for them, but they would just rank them. They would say, stars of the first magnitude, stars of the second magnitude, stars of the third magnitude, and it would be like ranking. So as the level of the number went up, the stars were dimmer. And it was just kind of a subjective thing. But then they tried to put a number on it. And then eventually find out that there was such a thing as stars of 0 magnitude and stars of negative magnitude. And I think that's what kind of blows people's minds. If it was all just positive numbers, I think they'd get it. But when it goes negative, it gets a bit confusing. But yeah, so thanks for that. So I'm going to start with Orion for a couple of reasons. It's wintertime, and Orion, I think everyone can agree that Orion is the most prominent constellation in the sky. I mean, it's not the biggest, but it has the most number of bright stars kind of concentrated in one area. It's very evocative of a human figure. So, and being on the equator, which will come up later, it's visible to, I would say, the entire inhabited world. Everybody all over the world should be able to see Orion, and in fact, there's a lot of mythology associated with the constellation. But there's a personal reason why I would like to start with Orion, and that is because it is, in fact, it goes back to like day one in my journey in astronomy, and that is over 60 years ago when I was 8 years old, living in Winnipeg. My father took me outside and showed me the Big Dipper, and he showed me Orion. And this memory is seared, it's seared in my memory. This is how I started with astronomy. And he also showed me how from Orion you could go to other places in the sky to see other stars. I don't remember that so much. I might have conflated the memory of my father with some other stuff I might have read, but that's when David Chapman, the amateur astronomer, was born, and so that sticks with me. And so what we're going to do is we're going to start with Orion and look at the bright stars in Orion, and then from Orion we're going to go out and spread out over the sky and find some other bright stars. So this should be helpful for the absolute beginner who's just learning the sky. And there's other constellations that you can use for this in different seasons. So let's jump right in to Orion. And of course, the first star that I'm going to talk about is Betelgeuse, which is Alpha Orion. That's actually not the brightest star in Orion. That's another story. And it has, the name Betelgeuse has a number of different interpretations, all relating somewhat to the shoulder of the giant. Perhaps the left shoulder, I don't know. And then there's other more fanciful names for that star in English, but Betelgeuse is the one. And of course, there's a famous film by that name. So when I told my grandson that star was Betelgeuse, he got very excited. And suddenly got interested in astronomy, like Betelgeuse.
If I say it 3 times, what happens?
Yeah, I know. And so anyway, it's magnitude 0.5. So it's a variable star, and it's a M2 orange-red supergiant. So it's on the red side of things, which means it's a cooler star than the sun, and it has about 20 solar masses. Now, what makes it a supergiant, I think, is not so much how much mass it has, but how physically big it is. And I don't have that. But I do know that it is like the second or third largest star in terms of apparent angular diameter. Like, I think with the Hubble Space Telescope, they can actually resolve the disk of Betelgeuse and actually see variations in intensity across the disk. And so it's like 50 milliarc seconds. And there's only a couple of stars bigger than that to the telescope. So it's the 10th brightest star in the night sky. And what I say from now on, when I say it's such and such brightest star, I'm not including the sun. The sun is obviously the brightest star, but the numbers I'm giving are, just imagine I'm in the night sky, right?
Yep.
So it's a fairly bright star, 10th one, and it's mostly bright because it's near to us. When I say near, all of the stars, I think, except one I'm going to speak of, are less than 1,000 light years, and that in a galactic sense. The galaxies, I don't know, hundreds of thousands of light years across. Anything that's closer than 1,000 light years is pretty darn close.
Yeah, for sure.
And I guess if you get into structure, is there an Orion arm of the galaxy, of the Milky Way, or something like that?
I believe so.
And so we're looking away from the galactic center. So the Sagittarius, the galactic center, is behind us, and we're looking out of the galaxy, looking towards Orion, but it's the closest arm to us. So we're looking across the galaxy, out of the galaxy, but this is one of the closest stars. So
if you see my, sorry, Dave, if you see my eyes wandering, it's because I've got my pocket sky atlas out and I'm following along here.
So the only thing more I want to say about Betelgeuse, there's much more you could say, but it famously dimmed in, was it how many, 3 years ago now, or 4 years ago? In late 2019.
Remember, well, it was right before the pandemic. Maybe
I think it's yeah, you're right. It's 3 years ago. So it was December 2019 into February 2020. Everybody got excited about Betelgeuse because it dimmed by a huge amount. And people were saying, oh, it's going to go supernova, and because this is what happens when a red giant, supergiant dims, it's getting ready to blow up, and everybody got excited, and even I got sucked in, and I was out there actually doing visual estimates of a Betelgeuse magnitude and sending my data into the American Association of Variable Star Observers, and my data's there. It's in the graph, and we were using nearby stars like Aldebaran to be the comparison stars. It was a lot of fun to do that. So could you just go out and look? You didn't need any special gear or anything. You just look and say, well, is it brighter than that, or is it dimmer than that? Little tricky because it's red, but anyway, it turned out to be just a gas cloud that was spewed out of the star and kind of wandered across the face of the disk. And I think that's what they figured out in the long term. That's why Betelgeuse dimmed that time. So on the opposite end of Orion, down at the lower right, I guess, is another bright star, Rigel, which is confusingly called Beta Orion, because alpha, beta, gamma are supposed to be the order of brightness of the stars in a constellation, but that rule isn't followed very well. So it's a magnitude 0.2 star, which is by the crazy magnitude system actually slightly brighter. It's a variable double star, and rather than being red, it's first of all, it means the foot. Rigel is the foot, and the foot of Orion. And it's a variable double star. It's a B2 white supergiant. So quite the opposite of Betelgeuse. It's a very hot white star. It's about the same. It's about 18 to 24 solar masses. And it's the seventh brightest star in the sky.
We also have to say that it's home to
Oh,
Kodos and Kang, isn't it?
is there a Star Trek
No,
reference here?
it's from The Simpsons.
Oh, okay. Yeah, sorry. I'm not up on pop culture. So, and these stars are important not only for themselves, but we're going to use them to find other stars later. So Rigel, the only other star which has a similar name in the sky is a slightly different spelling. Rigel Centaurus is in the foot of the Centaur. In other words, the star Alpha Centauri, which is the closest star system to the sun. We can't see it in Canada. So anyway, it does show up, that name foot does show up elsewhere in the names of the stars. Moving on, we're now going to consider Bellatrix, which is the other shoulder of Orion. It's Gamma Orion, and the name of Bellatrix means female warrior. Which you could almost guess if you took any Latin in high school, like me. Bellatrix. Bellum is war. So if you feminize that, it's Bella. Bellatrix is a female warrior. I don't know much more about the name there. And it's a magnitude 1.6. Again, a B2 blue-white giant. Not so big, 8 solar masses. I don't have much more to say about Bellatrix, but it's important in finding other stars. Now the next star we want to talk about, I want to talk a bit more about the belt of Orion. There's 3 stars in the belt of Orion, which is quite a dramatic grouping of stars in the sky. A lot of people recognize that.
It's the only set of 3 stars in a row like that. That's
that
bright, not straight.
It's interesting because almost invariably every summer at Kejimkujik National Park we'll have like a sky thing going on for the Perseus, or in the middle of August, and there's always somebody who says, "Show us Orion," and we say, "Well, no, we can't because it's a winter constellation," and everyone goes, "What?" Like, what do you mean by that? Okay, well, we have to explain, about how the sun goes, the Earth goes around the sun in different seasons. At certain times of the night, you only see portions of the sky. But it's invariable somebody wants to see Orion in August when it's really a winter constellation.
Yeah, those words about a circular Earth and going around the sun, that then can be fighting words in certain circles, yeah.
Okay, I guess so, yeah. Well, all right.
Yeah, I always think of...
Did I say it wrong?
No. I always think of doing some star parties and then people going, so we go around the sun? People really...
Oh, I've never had anyone question that.
Oh, really?
No.
You've been lucky.
Yeah. Now, the center of those 3 stars, you could have picked any one, but the center one is the navigation star, and it's called Alnilam. And it's Epsilon or Orion. And the name comes from string of pearls. Well, it's... doesn't take too much imagination to see why how you'd come up with that name, string of pearls. So it's about the same as brightness as Bellatrix. It's magnitude 1.7. It's also a variable double star. I put these things in just not really to talk about their variableness or their doubleness, but just to show how there's an awful lot of double stars out there and an awful lot of variable stars. People think of stars as being kind of very ordinary objects, solitary and steady, but many are variable and many are double or multiple. It's almost more common than being solitary. And it's another B0 blue-white supergiant. It's 40 solar masses. It's a massive hot star.
Wow.
The only reason it's not so bright as some of the other stars is that it's just further away, and I didn't notice. I didn't write down how far, but that's your homework assignment. How far away is Alnilam relative to, say, Sirius or one of the other brighter stars? So the 3 stars are Alnitak on the right or east, Alnilam and in the middle, and Mintaka in the west.
And I think Dave, I think Alnitak is a notable star because I think if you're looking to measure an eyepiece field, I
Oh
think
yeah.
that's a good one to use because it's right on the celestial equator, so it's easy to do your timings to figure out your field of view and stuff like that.
Well, they're all pretty close. I think Mintaka, actually, if you want to check your Mintaka is actually the closest. It's only 20 minutes of arc. But thank you for mentioning that because I'm going to speak to that in a minute. So I've did a bit of research, and in the Mi'kmaq culture, the three stars and some of the smaller stars around them are they talk of them as three chiefs fishing, and so the three chiefs are the three stars, and then there's dimmer stars associated with them that you can imagine would be their fishing pole or their fishing line. So the Mi'kmaq call that three chiefs fishing. And here's a new one to me. Somebody came up to me last summer, and she was speaking with an obvious Spanish accent. And I was interested because I've been learning Spanish for a couple of years, and I recognized the accent. And she asked me if it was the Three Marys.
Oh,
She was looking at Altair and the three stars, and she said, "Is that the Three Marys?" I said, "No, I've never heard that before. Like what?" And she started talking about these Three Marys, and I said, "I'm going to have to look that up." Well, it turns out that what she was looking for was Orion.
oh,
Interesting.
and she was looking for the three belt stars, which in Spanish-speaking countries are called the Three Marys.
Oh.
I asked my wife who they were: Mary Magdalene, Mary Mother of Jesus. I guess it's another Mary, but not being a Catholic or barely a Christian, I don't know. So that's another homework assignment. Who's the third Mary in the Three Marys?
my wife's name is Mary, so maybe it's her.
Yeah. So, but okay, good. Now you brought up the fact that Orion spans the equator, and in particular the belt stars are very close to the equator. Alnilam is actually just 1 degree south of the celestial equator. So you're right. Timing Alnilam or any of those stars, it probably wouldn't make much difference. If you timed the transit, you could convert the timing across the field of view of your optics. You could convert that into a field of view easily. What is it? 15 degrees is 1 hour or something like that. Yeah.
Exactly.
Hopefully, it wouldn't take that long. But this is something that I discovered for myself. I mean, it seems obvious in hindsight, but when you have something prominent that spans the celestial equator, like the belt of Orion, that wherever you are on Earth, wherever you're looking at that thing, that rises in the east and sets in the west. And that came home to me about 10 years ago when I was down in New Zealand and looking at all this stuff upside down. And I was watching Orion set with the belt of Orion and Sirius above, and I was going crazy trying to figure all the geometry out. And it suddenly dawned on me that wherever you look at Orion from, setting or rising, it's east and west. So what an amazing navigational aid that is.
It is.
If you get lost, if you're out in the middle of the Pacific Ocean in your canoe, wondering which way to go, watch for Orion to rise or set, and Bob's your uncle. So that's kind of a self-discovery there. But in hindsight, it makes sense, right?
Yeah.
So the one star that I'm not going to talk much about is Saiph, which is Kappa Orion, which is the other foot of Orion. It's not a particularly remarkable star. It's the dimmest of that group. But I'll just mention it in passing that it's there. In case anybody wanted to know what the name of that star was. So now it gets fun because now that we know Orion and the belt of Orion, we can move on. And I'm going to move on to the constellation of Canis Major, the great dog. And the brightest star in the sky is Sirius. And in order to find Sirius, you follow the belt of Orion down and to the left. And you find Sirius. You can't miss it. I mean, it is, in fact, the brightest star in the sky. If you see anything brighter, it's either Venus or something terrestrial, or maybe a supernova if you're lucky. Anyway, Sirius is Alpha Canis Major, and there's no debate about this. It is the brightest star in the sky, therefore it is the brightest star in Canis Major, and its name means scorching because it's so bright, and people people recognize that. So it's one of these negative magnitude stars, magnitude minus 1.4. It's a double star, which we'll get to, and it is a A0 white. Interestingly enough, main sequence star, only 2 solar masses, and yet it's the brightest star in the sky. And well, it's only 8.7 light years away. Now, the nearest star, period, is only 4 light years away, and from Canada, we can't see it. So Sirius is, in fact, the closest star visible to the naked eye from our mid-northern latitudes. So there's a little trivia fact you can throw in at your next star party. To see anything that's closer, you have to go south. You don't have to go all the way south, because you can pick up Alpha Centauri from the Florida Keys, places like that. You can pick up Cuba. You can see Alpha Centauri, but it's all of the nearer. Well, that nearest star is a southern star. So now here's the fun part. It's called the dog star because it's the main star in Canis Major, one of the hunting dogs that accompany Orion. But the Egyptians used it. They used to look for its heliacal rising in the summertime. Now, do you guys know what that means? The heliacal rising?
Something to do with the sun.
Yeah. Shane, do you?
No,
I don't. Okay, so this is something that the ancient astronomers were really keen on. So what you do, imagine you're waiting to see Sirius in the sky, and it's summertime, and it's a winter constellation. It's just disappeared a month or two ago in the evening sky, and you want to see it again in the morning. So you go out and you wait, and you wait and you wait and you wait, and you don't see it. And the sun comes up, the sky gets too bright. So you go out the next day. Eventually, there's going to be a day where you're looking for Sirius in the east, and you see Sirius for like a minute, and then the sun comes up and drowns it out. That's a very precise moment in time, and that's called the heliacal rising, and you can use this for anything. So that is a very specific time on the calendar. The first time you can see something in the morning sky before the sun comes up. Before that date, you would not be able to see it. And after that date, you would be able to see it longer and longer and longer in the morning sky before the sun comes up. But the heliacal rising is that day when it first appears and then disappears because of the sun. And I've actually gone out in the middle of August and photographed Sirius in the dawn sky with Orion and all that. And it is the middle of August. And at the time, it used to be associated with the flooding of the Nile. So it was a very important date in the agricultural calendar. That's no longer true for a couple of reasons. The seasons have shifted around a bit. Plus, they put in the Aswan Dam, so the Nile doesn't flood anymore. But here's the cool thing. Have you ever heard the term dog days of summer?
Mm-hmm.
Okay.
Yep.
The dog days of summer are associated with the heliacal rising of Sirius, because when you see Sirius, it's the middle of August and it's hot. And so that's where the term dog, and Sirius is the main star of Canis Major. So it's the dog star, and these are the dog days of summer. That's where that term comes from. Pretty cool, huh?
Yeah, pretty interesting.
Well, got one more interesting story about Sirius. Frederick Bessel, the mathematician, and I guess, I don't know if he did any observing himself, but people were taking accurate positions of stars with telescopes and that. And he noticed that there was like about a 50-year oscillation in the position of Sirius based on observations that different people took. And, if you plot them out, you see it's wobbling. It's wobbling back and forth. And I believe he speculated that it might have been a companion, but nobody could see it. Well, I don't know the dates, but later on, there was a well-known telescope maker named Alvin Clark, and he was testing out one of his big refracting telescopes, which apparently is... Yeah?
26 inch. I think it was the 26-inch one.
Okay, could be. Yeah, I didn't know if it was that big, but it could be. It's a detail. But that telescope is still in operation today. And he observed this tiny star next to Sirius, and it turned out to be a white dwarf. Sirius B was discovered by Alvin Clark visually while testing his new refractor. Now, the orbit of Sirius B around Sirius is quite elongated. So there's times when it's way, way too close to Sirius to be observed. And there's times when it's quite a distance out. And I didn't correlate when he did his observation with the orbit. But at the current time, it's actually in a very good position to observe. Now, I've observed Sirius B in a telescope at the Winter Star Party with great difficulty, but I did observe it. It made sense to me. I saw it, and it was where it was supposed to be. So it's an interesting challenge observation if you want to give it a try.
Mm-hmm. And maybe just a reference back to Rigel. The separation between Rigel's primary and its companion star is about the same distance as Sirius.
Okay.
And Rigel's companion, I believe, is about the same magnitude as Sirius B. So if you're wanting to attempt the split of Sirius, I always like to start with Rigel. And if you can split Rigel, try for Sirius. But if you can't even split Rigel, if the conditions aren't supporting that, I wouldn't even bother with Sirius.
Yeah, okay. Well, anyway, it's worth, for the power observers out there, you should give it a try.
Absolutely. Yeah.
Now, there's a whole, you could go on about Sirius for a whole episode. In fact, somebody wrote a book that's only about Sirius. It's called Sirius, Brightest Diamond in the Sky by Jay Holberg. And it's a fascinating book. You should read it. It's an amazing book.
I would have called it Sirius Observing, but that's just me.
Yeah. So some people call the Sirius B white dwarf the pup because it's the companion to the dog star.
It was the 18.5-inch. So,
okay, yeah, I thought it was something like that.
Yeah, wow. They tested 18.5-inch.
So the other star in Canis Major, once you found Sirius, you just pop down farther south, and you find Adhara, which is Epsilon Canis Major, and it's called the Virgins. It's another one of these B2 blue-white giants. 13 solar masses, so it's more massive than Sirius. And now get this. Even though it's only magnitude 1.5, its true luminosity, it's more luminous than Sirius is. But the reason it's so dim is that it's 47 times more distant. So that's pretty cool. Like a very good, in one constellation, a demonstration of how distance affects the brightness of stars, and not just their natural luminosity. The other thing about Adhara is that in ultraviolet light, it is the most luminous star in ultraviolet. I don't know what that's all about, but it makes it special. And they think that it used to be brighter than Sirius because it was closer. But this is like millions of years ago.
Interesting.
Now, let's go from Orion again and go up and to the right, following the belt of Orion. If we go up and to the right now, about the same kind of distance, we find Aldebaran, which is Alpha Taurus, the brightest star in Taurus. Aldebaran means the follower, from the point of view that it's always following the Pleiades star cluster in the sky. So it was given the name the follower. There may be more to that than I'm suggesting. That there may be a bit of a story behind that, but I didn't get a chance to get into that. So it's another one of these variable multiple star systems. It's magnitude 0.9. It's a K5 orange giant. Now, see, they call it a giant, but it's only 1.2 solar masses. So I'm guessing the giant, supergiant thing has something to do with more of its physical size, that it's much broader than the sun. Because, interestingly enough, the sun is considered a dwarf star. Did you know that? There doesn't seem to be any normal stars. There are giants, supergiants, and dwarfs. There's an article in the RESE journal somewhere that somebody wrote a few years ago. It's a whole article about how the sun is not an average star. I wish I could find it, but it's a very interesting article. The sun is not an average star. So it's among the Hyades star cluster, which is one of the closest open clusters to us, but it is not associated with the Hyades. It just happens to be in the way. And on a personal note, it was one of the comparison stars I used when I was estimating the magnitude of Betelgeuse 3 years ago. And it was a particularly good one because it was also a red star, red, orange, whatever. It's very difficult to compare the brightness of a red star with that of a blue star or a white star because the colors are so different. So it was a challenge, but Aldebaran, like you could see right away, was brighter or dimmer than Aldebaran. That was like the first thing you'd look at, and then you'd look at some other stars to try to fine tune it. So having found Aldebaran, there's another star in Taurus that's of interest, and it's called Elnath. And to find Elnath, go back to Orion, and you've already found Rigel and Bellatrix, and you go up north, you go celestial north, you go up from Bellatrix, Rigel through Bellatrix, and up quite a ways, and you find Elnath, and it's one of the horn stars of the constellation Taurus. And it's a navigation star, Beta Taurus. Elnath means the butting one. You can imagine, a bull butting you with its horns. Mm-hmm. And it's a magnitude 1.7 double star. Another B7 blue-white giant, 5 solar masses. And I'm going to get back to this later, but Elnath once was associated also with Auriga. So in some older star charts, you'll see Auriga, the charioteer, the line diagram going down and connecting with Taurus at the star Elnath. In other words, Elnath was considered to belong in some ways to both constellations. But that idea got tossed out by the International Astronomical Union when they reorganized things back in 1930. They said, no, you can't have a star belonging to two constellations. You have to choose. So they chose Elnath to belong to Taurus. And so that's how the charioteer lost his foot, by having Elnath taken out of Auriga. There's another star, Alpha Andromeda, is part of the square of Pegasus, but it's now considered Andromeda and not Pegasus. So I don't know how many stars there are like that in the sky. That would be an interesting research project. So we're done with Taurus, and we go back to Orion again, and now we follow Bellatrix. The two shoulders of Orion go from Bellatrix through Betelgeuse to the left and farther east, and you go a ways and you find a bright star named Procyon. It's the 8th brightest star in the sky, not that far away, 11.5 light years. It's a magnitude 0.4, another variable double star. It's an F5 blue-white main sequence star. It's a main sequence means it's not a giant or a white dwarf or anything like that. It's doing its thing. It's about 1.5 solar masses, so not that much different from the sun, maybe a little bit hotter. Now here's the cool thing. The name Procyon, it literally translates as before the dog. In Greek, the word for dog used to be Kion or Scion. So what we call Canis Major, the great dog in Latin, to the Greeks was Kion, the dog. And obviously Sirius is the brightest star in that constellation. But because Procyon, even though it's so much farther east in the sky, it's also very much farther north. And you can verify this for a fact. Procyon rises before Sirius. And so it ended up with the name Procyon because it rises before the dog, the dog star, which I only learned that a few years ago, and I thought that was an interesting little story about that star. Now, go back to Orion. You can see why I started with Orion. Mm-hmm. You go back to Orion. Now you take Rigel and Betelgeuse. You follow Rigel through Betelgeuse across Orion and keep on going, and you find the twins, Gemini, the twins, Castor and Pollux. I'm only going to talk about Pollux because that is the navigation star. Beta Geminorum, so I think it's Beta Geminorum. And as far as I can make out, the name means one of the twins. So I'm not sure how that relates to Castor, but it's a magnitude 1.2 variable star. It's a K star, so it's a little cooler. Yellow, white. It's another giant star, 1.9 solar masses. So all these bright stars have turned out to be quite often giant stars. Not too surprising. Nothing much more to say about Pollux. Castor is Alpha Gemini, but again, I don't think it's because I think Pollux is still brighter than Castor. So there's another case where Alpha and Beta don't correspond with the brightest stars. Now, here's a little mnemonic that I discovered quite a while ago. You look up and you say, well, there's Castor and Pollux, but which one's which? How do you know which one's which? And my friend Dale Ellis told me this. He said, oh, Pollux is the one that's closest to Procyon. Mm. And Castor is the one closest to Capella. Now, we haven't met Capella yet, but if you know where Procyon and Capella are, then you know which of the twins is which, because Procyon, or Pollux, is closest to Procyon, and Castor is closest to Capella.
That's cool. I hadn't heard that before.
No, yeah. You learn something every day, right?
Yeah, that's a great tip.
Thank you for me.
When you look up at them, you see that they're the twins, but do you ever remember which one's which? I mean, honestly, like when you just look at them, Castor and Pollux, which one's which? I always had trouble figuring that one out. Mm-hmm. Okay, so we're winding up here. We just mentioned Capella, and to find Capella, not hard to find. Go back to Orion, and go back to Rigel and Bellatrix again. If you follow Rigel through Bellatrix to Elnath, keep on going, and eventually you find the constellation of Auriga. Now, Capella's not exactly in line, but it's close enough. It's a pretty bright star. Now, Capella is obviously, it is Alpha Auriga. Auriga is the charioteer. No one can figure out why the charioteer is carrying a goat and two kids. I haven't been able to. Somehow he got encumbered with this farmyard animal on his voyage. But Capella is the she-goat, and it's a magnitude 0.1. So if you wanted to know like what a magnitude 0 star was, Capella is a good example. And it's another variable multiple star. It's a G6 yellow-orange subgiant, 2.6 solar masses. Not too different from the sun, I guess. And it's the sixth brightest star in the sky. It's very far north. Like here in Nova Scotia, I've sat on the edge of a lake, and I've seen Capella when it's really close to the tree line in the middle of summer, where it never sets. You can follow it. You can see Capella moving its way across the tree line on a clear night. So we're at about a little bit less than latitude 45. So in most parts of Canada, you wouldn't be able to see that, but it is barely circumpolar here. But of the first magnitude stars and brighter, it is the one that's closest to the pole.
Dave,
okay.
When you remember we started doing the constellations for the handbook, and Capella was one of the first. That was Auriga was
Auriga was the first one. Yeah,
I wrote about. And the reason why I chose Auriga was just for that reason, is that now we're a little bit further north, so it's a little bit higher, but I was observing in the grasslands near some really big hills. And so I was looking up, and I thought I was totally in the park alone. It was back in the days before they promoted the grasslands as a park to go to. And I looked up and I saw what I thought was another camper up there. I thought it was their flashlight, because it was just above the hill, like where somebody would be holding a light if they were like setting up a tent. And then like about half an hour later, I looked up again, and it was still about the same height above the hill. It was just over about 100 meters or 50 meters or something like that. And so like I watched, I'm like, this is really weird. And it just sort of gradually made its way across the hill. And after a couple hours, it started to rise up. So it's an interesting thing to see. Anyway, just sure.
Yeah, so stars like that, stars like Capella, spend an awful lot of time near the horizon. If you think about stars that rise and set and are circumpolar, they spend a lot of time near the horizon, are often reported as UFOs by people, because they sparkle a lot, and you see all different colors, and people get all excited that they discovered something. So those are the 11 winter stars I think you should know. I hope you feel that it was an interesting enough group, all connected through Orion. Do we have time to just talk about a couple of asterisms, or should we pretty much?
I think we're getting towards the end there, Dave, because one thing I was going to get you to talk a little bit about is the references. You mentioned a few references, Star Tales by Ian Ridgway.
Yes. Yeah. I'll just say that if you're going to post the notes, people might already be aware of things like the winter hexagon and the winter triangle, which are asterisms, which you can create from the stars I just described, and one that's new to me called the winter G. So those are in the notes. And if you look at the notes, you'll be able to figure those out. It's kind of fun. And I think I also provided a bit of an image for that. So, so the my go-to references, I mean, apart from the handbook, I didn't even write down the handbook, but I always go to the handbook first. But when it comes to things like star lore, I really like Star Tales by Ian Ridpath. He's a British author, and there's a new version of that, 2018, that came out, a revised version, and it includes a lot of defunct constellations, which I know that Chris would enjoy reading about.
Yeah, I've read. He has his old version online. Actually, one of the older.
Yeah,
he put it online.
Yeah, well, that's nice of him. I mean, but I always, for things like that, I always wanted to have like the latest, greatest. You know.
Yeah.
I think I gave mine away to somebody when I got my Star Tales book was a used book from a library, and I gifted it to somebody when I got the new version. The other one, it's a little bit more dense. It's a classic book called Star Names by Richard Hinckley Allen. It's a little bit harder to read, but it really goes into the classic origins and all the different, Mesopotamian and Persian and the different names. One of the things you get from that book is how, like, the stars we think of as the standard stars and the standard astronomy, I mean, it's just our convention. But, I mean, there's no end to the number of stories and names that stars go by. And that it's almost infinite, in Sky Safari 7 Pro, or all the Sky Safari, one of the reasons I like it is that the star lore, they didn't do it themselves. They basically went to this guy Jim Kaler, and he's online. Jim Kaler, Kaleer, and he's got a ton of star lore online. And they basically, I guess, got his permission. But all the sky lore that's in Sky Safari about all the stars is basically Jim Kaler's content. And so the easiest way to access that for me is just to go into Sky Safari, type in the name of a star, and go and just read the little article. There's so much information there. And of course, my another go-to book for astronomy, it's getting a bit long in the tooth, but A Concise Dictionary of Astronomy, 1991, by Jacqueline Mitten. This is always next to my computer because I'm always thinking, like, well, how do you spell that? Or what's the real definition of such and such a term, you know? And so I grabbed this book. I mean, it's old, but I think a lot of that stuff doesn't change with time, you know, nomenclature and whatnot. And it's really well thumbed. And it's just my reference book. It's like it's a dictionary, right? So obviously, I just say if I have any concern about anything, I just pop it open. I don't go on the internet. I pick the book up.
Yeah.
And so those are my sources, all well recommended.
Nice. All right. Well, do you have any other things to add here before we wrap this episode up?
No, I think I've gone on long enough.
Oh no, it was great. I really enjoyed it. You know, thanks so much for sharing all this. You know, I really like the idea of doing all these stars. These are stars that we all mention in the show like so many times, but to actually have them all sort of grouped together, you know, one spot. Or I guess if people like this, they should let us know, and we continue on with these every quarter. And
for sure,
create an ultimate reference there. Yeah, go ahead, Shane.
Oh, I was just going to say thanks, Dave. Really enjoyed it. It's interesting because when I think of stars, it's usually just as navigational aids, and the stories are more around the constellations, and the purpose is more of just so that I can find things to look at through the telescope. But there's so many stories associated with the stars and other interesting scientific information too, which I just really enjoyed this. So thanks.
Yeah. Well, thanks very much for being my guinea pigs. So let's see what people think about it. See if they'd like to hear more. I don't know if I'm not sure if the other episodes I have in mind are as sort of captivating as this one because of all the bright stars and Orion and so on. But I think we're just going to, if people are interested in doing that experiment, it'd be interesting to see, you know, if we did the next one, which would be like the North Circumpolar stars. Yeah. I think it would be a different feel, but I'm looking forward to preparing that if people are interested. So.
Yeah, I like the idea because we do often get questions from people that are maybe like even a little bit more than just starting out, kind of like we were talking about, you know, which one's Castor and Pollux and that kind of stuff. Like that's really going to stick with me that, you know, Pollux is won by Procyon and Castor's run LSI. You know, things like that are really helpful to those of us who've been doing it for a long time.
Well, that's definitely something that I added to this because I didn't read that anywhere else. That was something that I, you know, in my 60 years of doing amateur astronomer, that's one of those things that popped up and I've brought along with me to deliver to you today. So
yeah, because we get so many questions from people saying like, well, you know, it's all fun and good. You know, I bought the telescope and, you know, I've been going out under the stars, but, you know, I live in the city or maybe they don't have the perfect skies or really good skies, and they're just trying to learn their way around. I think things like this are helpful to people. At least I hope they are.
Good.
And we'll just ask for people to let us know if they like it. So thanks so much for joining us today, Dave.
It was a pleasure, a great pleasure.
Very good. Anything else to add, Shane?
Just a quick reminder, show notes will be available at actualastronomy.com for the references if anyone's interested.
All right. Well, thanks, Shane. Thanks for joining us, Dave. We look forward to doing some more of these in the future. And if you, the listener, enjoyed this podcast, consider giving us a 5-star rating, say something positive about the show. And that way you'll help others to find actual astronomy in 2023. And we're always happy to get your observing reports, questions, or show feedback. And we'd like to hear if people want to hear more of these, because Dave and myself and Shane are pretty eager to do some more of these. If people want to hear them, let us know. We can go through the entire sky every 2 or 3 months over the coming year. It'd be, I think, a neat way for people to learn a little bit more about the stars that they're actually seeing up there. You can get in touch with us at actualastronomy@gmail.com.
Thank you, everyone, for listening, and we hope you enjoyed the show. If you are interested in more information, would like to contact us, or if you would like to support the podcast, check out our website, actualastronomy.com.